All right, so let's have another shot at this. So with this reaction here, we established that if we were to turn this into words, it would be 1 molecule of methane. This is methane here. 1 molecule of methane reacts with 3 molecules of oxygen. So this here is oxygen, to produce 1 molecule of carbon dioxide So 1 molecule of carbon dioxide, we know it's 1 because there's no coefficient there in front of carbon dioxide, and 2 molecules of water. So this is the ratio. This is the ratio that we find all of the substances reacting in and being produced in. Now you can actually substitute out each of these words, molecule, with moles. So 1 mole of methane reacts with 3 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water. Okay? Whoops. Okay. Now what if a question was asking us, and this would be a 4-mark question, 12 grams of carbon dioxide was produced in the combustion of methane. I'll make this 2 parts actually. First, what was the mass of oxygen that was consumed and I'm going to add something new. How many particles, no, not particles, let's say how many molecules of methane reacted, or in all, properly worded, how many molecules of methane were involved in the reaction. So part A, we've looked at previously. Part B is a little bit new. But the process of mole ratios and stoichiometry is still common. All right. So we have the mass of carbon dioxide. This here is the mass of carbon dioxide. Now we have to convert in our units into moles in order to substitute and convert between different substances. So if we're going to convert between how many moles of carbon dioxide, how many moles of oxygen is required in order to make how many moles of carbon dioxide, then we need to convert these into moles. These both need to be moles. Our description here is based upon moles. So we have a mass of carbon dioxide. We can very easily convert that into number of moles by using this formula here. So N is number of moles, M is mass, and MR is molar mass. So the number of moles of carbon dioxide equals mass of carbon dioxide equals molar mass of carbon dioxide. Actually, we want to find number of moles. We have the mass is 12 grams. The molar mass of carbon dioxide, is going to be 12, which is the molar mass of carbon, plus 2 oxygen atoms. So each oxygen atom is 16 grams per mole according to the periodic table. And so when you add that together, that's going to become 44 grams per mole. And this goes here. So if we plug that into our calculator, 12 over 44, that gives us 0.273 moles. The question was asking us what was the mass of oxygen that was consumed. So we need to actually work out how much oxygen was consumed. So let's use the ratios method for mole ratios, for stoichiometry. The ratios method for stoichiometry. Now the number of moles of oxygen ratio to the number of moles of carbon dioxide, according to the equation, 3 moles of oxygen are consumed every time we make 1 mole of carbon dioxide. So it should be 3 to 1. So we just put like fraction lines here and an equal sign in between, and we get our mole ratio. And we do some rearranging of these fractions here to get that. Do we know what the number of moles of carbon dioxide are? Yes, we've worked it out up here. So we just bring that down. Right there. So we've worked out a number of moles of oxygen. Now the other way that we can work out number of moles is by using number of moles of unknown over number of moles of known is equal to the coefficient in front of the unknown substance in the equation, and B is the coefficient of the known substance in the equation. So the unknown substance is oxygen, so we go number of moles of oxygen over the number of moles of the known substance, carbon dioxide. The coefficient in front of oxygen in the equation is 3, yeah? And the coefficient in front of carbon is 1. There's nothing there, so it's 1. So we would write 3 over 1. And if you do some rearranging, number of moles of oxygen equals 3. So I just turn this 3 over 1 into 3 times number of moles of carbon dioxide. We know what number of moles of carbon dioxide is, so we bring that over. 3 times 0.273 moles. And that's 0.818 moles. Yeah, did I do that right? Yes. So I didn't do this calculation over here. This one should have been 0.8182. So I didn't multiply it by 3. All right. Now that we have the number of moles of oxygen, we can work out the mass of oxygen that was consumed. So we just convert these number of moles into mass. So now we want to find mass of oxygen, and by just rearranging this equation here, mass of oxygen is number of moles of oxygen multiplied by the molar mass of oxygen. Number of moles of oxygen is 0.818, we've established here. Molar mass of oxygen is, well, there's 2 oxygen atoms. Each oxygen atom is 16 grams per mole, so it's 32 in total. So that's 26.2 grams. That was the total mass of oxygen that was consumed. All right, and that would be a 4-mark question at this level. How about the second question? How many molecules of methane reacted if we had 12 grams of carbon dioxide? So we need to work out methane, the number of moles of methane that was consumed. Now, because this question is asking for molecules, we're probably going to be using this equation here. This equation here that looks at number of particles. And remember, particles can refer to either atoms or molecules. And if this question is asking us how many molecules reacted, we need to use this equation. But in this equation, we still need to know the number of moles. Yeah? So it's probably a good idea, or it's necessary to convert to determine the number of moles of methane. So how do we work out number of moles of methane? I'm just going to use the shorthand method, quick and easy method. Number of moles of methane, number of moles of the unknown, over the number of moles of the known, which is carbon dioxide. If you look at the equation, methane here has a coefficient of 1, carbon dioxide has a coefficient of 1. It's going to be 1 over 1. Therefore, number of moles of methane equals number of moles of carbon dioxide. We know what the number of moles of carbon dioxide is, just over here. This here was the number of moles of carbon dioxide. So we can say with confidence that the number of moles of methane are 0.273 moles. If we want to work out the number of particles of methane, we use this equation here and we rearrange it. We rearrange it for number of particles equals number of moles times Avogadro's constant. So number of moles of methane times by Avogadro's constant, 0.273 moles times by, Avogadro's constant is given on the formula sheet, but it's this, 6.02 times 10 to the 23. If we plug that into the calculator, we get 1.64 times 10 to the 23 molecules. This is how many molecules of methane reacted to produce that mass of carbon dioxide that was described at the beginning. Okay.